I'll be talking about video creation today. We'll talk about capturing from screens and connected webcams, assembling from just pure 2D images, static images, touring around 2D and 3D images and graphics, folding, nesting from programs, animations, manipulates. And last but not least, I'll talk about all the small but really, really useful editing and composition capabilities that allows everyone to package their potentially small snippets of videos into one impressive larger video. Okay, so let's begin. Simplest functions are simplest video creation functions are capturing from screens or from the webcams. We have two functions that would allow for capturing from webcam. So that's me again here talking. I can start recording, stop recording, a video object comes back, just like that. Similarly, I can capture from my screen. This is the screen I'm sharing right now, so I'm capturing that. Similarly, I can start and stop. There are programmatic ways that can allow doing the same things, recording from a screen or recording from any connected device. And then through functions, video stop, video record, pause, and things like that, one can programmatically move towards whatever kind of recording that needs to happen. These could obviously be conditional. If something happens, stop the stream and things like that. As the stream happens, I can in fact do any other computation that I want. That's why stopping, pausing, reacting on condition can still happen. So let's move on to some other simple, basic, but useful video creation techniques. Constant video is one of the newer additions, but probably the most simplest one. I pass one image to constant video, and 1 second or any second, I can add a second argument of durations like 5 seconds or a quantity 5 seconds there and get as long as I want of that video. Slideshow video basically has a default duration. This one by default creates a 5 seconds. Similarly, we can specify how long of a video we want, but basically divides that linearly between the images that are passed to slideshow video. However, one can specify explicit durations for the different frames that are being displayed there. The third function that would take us from a series of images to videos is frame list video. There we have a full list of frames, one by one, that need to be encoded into a video object. Here, for instance, I have an example that I'm nesting an operation like image restyle on that fish image. I do it 2 times, so I get 3 images, including the initial seed. If I repeat that so many times, 50 times, I get 51 images back. And I'll go in and plop my list into the function frame list video, and I get exactly all of those 51 frames. Again, here we have some default frame rates, all of those, or I explicitly set 15 frame rates, so roughly 3 seconds of video comes back. These parameters all can be adjusted. And here I'm creating a time series, for instance, from that geo variant of Roman Empire and get the polygons back. Then I go ahead and use slideshow video. I could have probably also used frame list video. And then I run something like time series map, create geographics of the polygons that are constructed with whatever function. And then I go ahead and label my plots with a label that says what year that map is extracted from. With a duration of 20 seconds or whatever is desirable, this is basically showing the year on the top, or could be on a corner or whatever, and then showing how the map evolves over basically centuries. Very recently, tracking Hurricane Helene, Arnaud from Wolfram Research basically got a source of images that was showing satellite images of the hurricane reaching the US. And then somewhere at the end of his exploration, he is basically passing those frames that are being downloaded, extracted from the website into one video. And here is a amazing video showing how the hurricane is approaching the US. Another example that caught my eye very recently, and I was pleased to see again video is being used, is showing off the power of ND-solve. So here PDEs are being set up and solved and all of that. And at the very end, again, in the core of this function, there is a frame list video that puts all of those generated frames into one video showing how basically the equations were solved. So we'll move on from assembling images to touring 2D and 3D images. This is also not a new function, but has evolved quite a bit over the few versions that it has been released. One of the uses of touring large images or touring images is when the image is really large and it's hard to see details of the images. So here I have a simple example where I specify positions, width, and the width is fixed. So this one is basically panning and zooming on that image, going from one side of an image to another. The position changes from that XY coordinate to this one, and the width goes from 3000 to 200, which is showing that zooming, and then the panning is the position change. Another fun tour, we have specified this spiral path. And then if I highlight the path on the image, this is how we are spiraling. And then tour video of the image, path gives us an image that basically follows the path on the image. Same function, tour video, is also enriched with geographics. So I can just pass geographics here and say I want to go from one city to another. And then here is a linear travel from one city to another. As I was just creating this, I was thinking something like travel direction would be interesting as well. So instead of just linearly going like a flight direction from one city to another, I have computed the travel directions and I go from one city to the next one as if I'm driving on the map. 3D tours got added more recently compared to 2D tours, simple rotations around 3D graphics and regions. By default, Tour 3D video is basically rotating around an object that is passed. It has all its, as usual, beautiful defaults on how big of a radius I need to choose to rotate around the object so that I see more of it. However, similarly to what we said for tour video, we can specify a specific path. Here we have a position defined as a function of t, and then I'm showing the path that we're taking around our castle using parametric plot 3D and show. And then here I'm doing a tour around my geometry G using that position function that was specified. And one thing that's probably nice to mention right now as we're waiting is that we have upgraded most of our progress monitors to show basically a preview of what's happening in the video generation. So that has become really easy to spot potential mistakes and pause the creation of the videos. And that takes us to creating videos from programs. So video and Reap video are the newest of the video creation families. Just like sow and reap, where some expressions can be sown from whatever computation that is happening and then reaped into the final computation. We have added these two functions, sow video and reap video. Sow video actually has an argument that can say, repeat this frame that was sown so many times or for such and such duration. So what's happening here, I'm using a construct like nest while list. And after thinning that image, I'm pruning the image one pixel at a time, which is that list of one. And I will sow all of those frames, but I also ask nest while video to wait or pause, finish, whenever my frames, or as long as my frames are unequal, comparing two frames at a time. And then whatever got sown gets reaped into reap video. So here we can see nest while list, which is a very powerful nested iterative recursive construct, can be used in order to create such an animation. And all we needed was just to make sure we sow all the frames that are created and then reap them at the end into a video. Sewing on a condition is also pretty powerful. Here I have a video of a person practicing yoga. And what I'm doing is I'm saying, if you identify a face in that video, sew the video frame, otherwise drop it. And then all the sewn videos get passed to reap video. And here I'm getting a smaller chunk of the original video. Only frames are reaped or put into that resulting video if a face was detected. Another newer function is a fold operation. So basically, we get video frames, individual video frames, and fold whatever operation, just like fold list, on the frames of the video. This first example I have is showing basically a motion blur, where I'm going from a completely static, unblended frame into something that keeps blending the new frame on top of the previous frames, giving me that kind of a motion blur. Another neat example we had was a batter here. And in that motion, in a construct like remove background and compose, oh, actually, I had it already up there. We basically remove all the background and compose whatever foreground that remains from that on top of each other to get such a neat effect. One other sneak peek that is not yet released, fold pair, we realized was another really powerful functional construct that we had in the system. And it's very useful in helping us keeping states. So in cases like tracking bees or tracking ants or stabilization or anything that needs to keep some kind of a state, something like that fold pair is really useful. So even though we didn't release it as a system function, I think this is a very useful construct. So I'm demoing it. We've put it under the video context, but we're still thinking about if the design makes sense or if all the other constructs we have are enough. What I'm doing here, I'm starting from an initial set of points, which gets passed to my function f. And then here with something like image feature track, I'm passing the current frame and previous set of points. And then I specify whatever constraints, like I don't want my points to move beyond 15 pixels or whatever. And then with this kind of a function f, where we have the new frame coming in as well as the state being the new set of tracked frames, I pass the function to this video backtick video frame fold pair, and then I pass the video object to it as well. I get the first out of the function in order to get the new set of points that get passed to the next frame. And I say I want 2 frames at a time, shifting 1 frame at a time. That number of frames and offset is a very common set of parameters that we have in some of our other functions as well. So I start from the initial set of points, and as you see, each point is being tracked using our function max image feature track. You've already seen a glimpse of creating videos from animations. I'll go through simple examples like this one where I have a function that transforms an image. If I animate that function, this is an animation with a control that I can move back and forth. The exact same piece of code if I replace animate with animation video. And this one creates a video instead of an animate or manipulate object, and basically creates the same effect, but put it into a video object. Another example I have here is evolution of a cellular automaton that is being passed how many steps I would like to animate that. The I is basically the steps or iterations in the cellular automaton function. And here I'm basically putting that evolution into a video object. There are very many interesting things that can be animated, including over time. This is, for instance, using astrographics, one of the most recent developments in the Wolfram language. And then with astro reference frame, I'm giving it a time of the day, basically over 24 hours of the day, we're looking at the sky. And this is what we basically capture into another video. And then I'll get to manipulates. Manipulates with 1 parameters are basically like animates. Here I have 1 variable. If I pass that to the new function in 14.1, manipulate video, I linearly go from h, the hue parameter, going from 0 to 1. And that's no different from animation video, taking h from 0 to 1, basically going through different hues. However, one can specify in manipulate video how to control the parameter h, or whatever parameter. So here I'm starting from 0 at time 1. I go to 0.5, pause for 2 seconds until time 3 at 0.5, and then continue to time 4 to the value 1 of hue. So that's a pause on cyan, and then continue to go forward. Manipulates with multiple videos would get more, with multiple variables would get more exciting. Do I increase H first, S next, then take H back, then take S back? Do I do simultaneously or what? And then manipulate video is a construct that I still think we can develop it further and further, that can help control all of that behavior of manipulate controls. So by default, controls are simultaneously updated. However, one can, similarly to what I showed above, specify how the controls should move. So here I'm doing the same behavior as I explained for H, increase, pause, increase. And then for size, the parameter S, size of the disk, I would increase it, then decrease it back to a smaller size. So that's the result of that control. There is a new option that is added both to manipulate and manipulate video called keyframe actions. One can, by default here, manipulate objects have bookmarks, and we can add to bookmarks. But if I pass a keyframes actions go to true, instead of add to bookmarks, you see add to keyframes. And keyframes are basically can be thought as timed bookmarks. So if I add to keyframes, give it a name or whatever, that basically shows up as that untitled keyframe. And one can specify keyframes programmatically. So if you have computed the placement and values for different controls, this is another way of specifying how keyframes should be specified. And then just like we had animate bookmarks, now we have animate keyframes, and this is basically doing that animation of keyframes. Manipulate video respects the keyframe options of the manipulate object, but also if you're passing your expression to manipulate video directly, then you can also pass your keyframe actions directly to manipulate video. So this is following that action that was specified. I would like to show a few small tips and tricks about editing and composition, because a lot of the times that short video that was created using the functions I showed so far is not enough of an exciting creation and final production. So small things, here I'm showing a constant video of something, some text. It's very common to have something called title slides in between video snippets. We have a construct like grid video, another editing function that can take, here I have 4 videos and put them into a grid with some spacing and all of that. Here I create another grid of videos based on some cheerleading example. Then I join basically everything together. I have a title frame here, my toothbrush brushing video, another title frame, and then the cheerleading example. So here's basically the final product with 2 title frames between the grid videos that are generated. And then the cheerleading. Another nice thing that can be done, you can overlay something on top of the video that is created. So here I just overlaid a frame, but this one could be my screen capture, my webcam capture, so my head basically there. Another interesting thing, video combine. I can actually add a audio. This one is something I grabbed from Wolfram Tunes. And then this one now is my final production of the mini video that has a logo, has audio and everything.